Good morning, honors chemistry students, and good morning to you, Dr. Belardi. Hope you guys are having a happy Friday. Let's just get into my subject, which is carbon filtering. Let's get into a brief introduction. Why did I choose this topic? Why did I choose carbon filtering over other subjects? My uncle works for a company called Calgon Carbon, and they specialize in the production of carbon and carbon filtration. And I have prior understanding of this. I, during 8th grade, had to participate in a science fair, and my experiment was I conducted an experiment testing the effectiveness of different types of carbon and their filtration. I used coconut, charcoal, and wood to see which out of those three types of carbon would filter the best. How does carbon work? How does a carbon filter work? Well, carbon is an adsorbent, and when contaminated air or water passes through the activated carbon filter, the carbon adsorbs the contaminants, but not the air and water. You can look at this diagram here and see the contaminated water is going through the main basin, goes through the activated carbon filter, and the activated carbon filter is grabbing those contaminants. Not all of them, but most of the contaminants, right? And then the treated water goes through. And now you're thinking, well, this isn't very effective. I thought that I was getting pure water when I put it through my filter that I have on the sink. No, this is why you hear of things called 3-stage and 4-stage filtering units, because a singular layer of activated carbon filter is not going to trap all of those contaminants. So they add more stages so that those contaminants can all be trapped and you're getting pure water. So the more stages, the more clean your water and more clean your gas is going to be. And activated carbon isn't a pure substance. It's not pure carbon. It's not just carbon. There are impurities in the carbon. There will be random double bonds of oxygen, hydroxide, and other molecules within the activated carbon. But don't I mean absorb? Absorption doesn't sound right. I do mean adsorption, which is an intermolecular attraction in the smallest pores of a carbon particle, resulting in adsorption forces. Now, when I say the smallest pores, the carbon adsorbs the contaminants into its pores, right? Which causes the precipitation of adsorbents from solutions and causes the condensation of adsorbent gases, right? And because carbon is adsorbing it and putting it into its pores, unlike absorbing something, when carbon adsorbs particles, the carbon, it doesn't expand, it doesn't get bigger, right? And a good way to see that is in this diagram right here of the fat man, right? In this one, he's adsorbing it. He has it stuck to his face, but he's not eating it, so he's not getting bigger. In this picture, he's absorbing it, so he's eating it, and therefore his stomach is getting bigger. You can also think of it in a different way. You can think of absorption as a sponge. You can think of it as a sponge. So when something is absorbed, the sponge gets bigger in the water, right? So when you put a sponge in water, it expands and it gets heavier, right? Now if you were to think of how carbon adsorbs something, if you were to put the sponge in the water and it absorbs the water but doesn't get bigger, that would be adsorbing something, right? But a sponge can't do that. Now let's talk a little bit more about carbon itself. Like, why do we use an activated carbon filter? There's over 100 elements, but we use carbon. Well, where is carbon? Carbon is found in the atmosphere, where it's part of carbon dioxide gases emitted through fossil fuels and when we breathe. So carbon is not hard to find. But carbon also holds the highest adsorption force out of all the elements. Out of all the elements, carbon can adsorb contaminants and other particles the best. What are some everyday uses you can use a carbon filter for? Because we've talked more about the industrial water basins, but now there are things that are in our homes that you may have that use an activated carbon filter. Brita water and Zero Water contain coconut activated filters. They have multiple stage carbon filters that filter out the water, right? Fish tanks, to keep your fish clean and to have them have a better environment to live in. Some fish tanks use activated carbon filters to make sure that their fish stay clean. And then certain face masks, like certain N95 masks and regular masks, use activated carbon filters. So if you're looking to buy some during this pandemic, I suggest getting one that says activated carbon on it. And then these are my resources. Thank you to Carbon Carbon for their help. And I hope you guys are having a happy Friday. Have a good weekend. Thank you for your time. Bye.